So today we're going to finish up the 5-4 notes. The homework associated with the end of the notes is the 5-4B on WebAssign. So go ahead, and we already did all of these examples yesterday. And now this is where we left off. So we're going to be solving log equations. So if there's only one log, what you can do is put the equation in exponential form and then see if you can solve. So again, remember the main idea here is if you're given something in exponential form and you can't solve it, try switching it to log. If it's given to you in log form and you can't solve it, then put it back into exponential form. And then also other techniques are going to be to use some of the properties, condense it down, and different things like that. So here, if there's only one natural log, we can convert it to the log base e and then put it into exponential form, or you could even just go from natural log into exponential. Just remember the base for a natural log is e. And then if there's one log on either side of the equal sign, we can do the one-to-one property where we cancel out that log on both sides and then solve what remains. If there's multiple words that say log in your problem, you need to condense it using the properties, using the product property, the quotient property, or the power property to condense it down. And then if we can get it into one log or one log on either side, then we can solve either using the one-to-one, or if it's just one log on one side, turn it back into exponential. Remember, the base of the log and what you're trying to find the log of are only defined by positive real numbers, meaning we can never find a log of a negative number, or the base can never be negative. And it can't be 0 as well. So when we're solving these log equations, we're going to have to check our answers. We're going to have to plug it back in to see if it makes the original expression negative or a 0. So let's go ahead and try some examples. So here, all we have is the single natural log. So what I can do here is if you want to put it into log form, you can. But really, all I'm going to do is turn this into exponential. Remember, when it's the natural log, the base here that's assumed is an e. So if I use my Bay trick here, and notice that this is the base, the answer, the exponent, what I'm doing here is e to the third power equals x. This is a calculator question. Now, if it said to round and approximate e to 2.71, you can do that. But I'm just going to use my calculator. Hit the E, find the E button where it raises it to a power, do it e to the third power, and x is approximately equal to, if I go to 3 decimal places, 20.086. Changed it from log form into exponential. I'm going from log to exponential. Again, the natural log, the base, like remember on the log, whenever there's not a number here, remember, this is always assumed to be a 10 that's in here. But when it's the natural log, this is a little e here. So again, if I use my Bay trick, I'm doing e to the second power equals x. And again, if I just do this on my calculator, I get x to be approximately, rounded to 3 decimal places, 7.389. The next one, I'm going to use my one-to-one property. Now, notice on this, if I take my answers and I plug them back in for x, it's not making anything negative because there was really no operation to do on it. Now, over here, I'm going to be using my one-to-one property. And I can use this whenever there is exactly the same log with the same base on both sides. All I have to do is cancel that out, and then I'm going to solve what remains. So I'm going to solve 5x minus 1 equals x plus 7. I'm going to move the x to the other side. 4x minus 1 equals 7. I'm going to add 1 to both sides. 4x equals 8, divide by 4, and x equals 2. Now, because my original equation that was given to me was in log form, I need to check this answer. Now, I'm not doing anything on the calculator. All I'm doing, if you want to do it on the calculator, that's fine. I'm just plugging in 2 into this expression and just making sure that that doesn't become a negative number. So all I need to do here is 5 times 2 minus 1. 10 minus 1 is 9. It doesn't make anything negative, so that side's good. And then over here, x plus 7, plug it in. 2 plus 7, this one's 9 as well. So I know that nothing became negative, so x equals 2 is a good answer. Let's try the next one. Now, this is a common mistake that students are going to make. They're going to say, oh, look, it's got the same log in front of each term. I'm just going to cancel each one of those log words. You cannot do that. You need to condense using your properties before you can use the one-to-one property. So remember, because I have a subtraction sign right here, this means that I can use my quotient property to condense this. So what I'm going to do here is I'm going to condense the left side, make this log 3x plus 14 over 5 equals log base 6 of 2x. Now that it's condensed, and now that I have a single log word with the base 6 on both sides, now I can use my one-to-one property, drop the log base 6, and solve what remains. So I'm just going to solve 3x plus 14 over 5 equals 2x. Now, what I'm going to do is I'm going to add a 1 to the denominator over here, and I'm going to solve this as a proportion. If you'd rather multiply both sides by 5 and get rid of the fraction, you can do that as well. It's up to you. But if I do this as a proportion, I'm just solving, I'm going to multiply this, and this gives me 10x. And then when I multiply this diagonal, 1 times anything is just itself. And now I can solve. I'm going to go ahead and subtract the 3x from both sides. And I get 7x equals 14. Divide by 7. And x equals 2 again. Now, because my original question was in log form, I need to check this answer. Now again, all I'm doing is plugging in every place that I see an x and just confirming that that expression doesn't turn negative. So when I plug it in right here, 2 times 2 is 4. 4 is not negative, works there. And then do the same thing here. 3 times 2 plus 14 is 6 plus 14, and I get 20. No negative numbers, all's good. I'm not trying to make sure that the two sides are equal. All I'm doing is plugging it in to make sure that it doesn't make the expression of what I'm trying to find the log of, is make sure it's not a negative number or 0. So for number 17, notice on this side, I've got a single log base 2 on both sides, nothing to condense here, so I can use my one-to-one property, get rid of the log base 2, and then solve what remains. 2x minus 3 is equal to x plus 4. I need to get my x's together on one side of the equal sign and my numbers on the other. So subtract x from both sides. X minus 3 equals 4. Add the 3. X equals 7. Again, my original problem was a log equation, so I need to plug it back in. So when I plug it in right here, I'm doing 2 times 7 minus 3. 14 minus 3 is 11. It's good on that one. And then when I plug it in here, 7 plus 4 is 11. It checks on both. X equals 7 is good. The next one. Notice they all have the same log. However, I can't just say, I'm just going to cross off all those log words. I must condense whenever there's a plus or a minus sign between these logs. Don't just say, I'm going to do this, this, and this. You will get it wrong. You must condense the left side first using the quotient property that we learned. So I'm going to turn this into log of 4x over 12 plus x and set it equal to the log of 2. Now that I have a single log on the left and a single log on the right, I can use my one-to-one property and get rid of the log. So you must condense before you can try to cancel. So then now what I'm going to do is solve what remains. 4x over 12 plus x equals 2. Again, I could solve it as a proportion by adding a 1. So I'll do the cross products. I'm going to multiply 2 times the 12 plus x, set that equal to the 4x times 1. I need to distribute. 24 plus 2x equals 4x. Get my x's together by subtracting the 2x. 24 equals 2x. Divide by 2, and x equals 12. And again, I need to make sure that I don't get a negative or a 0. So when I go up here and plug it in right here, 4 times 12 gives me 48. No negative, no 0, I'm good there. And then the same thing here, 12 plus 12, 24, no 0, no negative, x equals 12 is a good answer. So let's come on over here to number 19. So again, my goal here is to isolate that log. So I'm going to subtract the 5 from both sides. I have 2 times ln x equals negative 1. I want to isolate the natural log of x, so divide by 2. So ln x equals negative 1/2. And now it's in log form. I can't solve it in log form, so now I'm going to turn it and use my Bay trick. I'm going to go ahead and the little assumed base here is an e. So I'm going to use my Bay trick, B-A-E. This e is the exponent. It's not what I'm trying to find the log of. So the things that can't be negative are the things that go right here. The answer can be negative. Everybody with me on that? Okay, so if I use my Bay trick, I'm doing e to the negative 1/2 power is equal to x. Again, take out your calculator. And this is going to approximately give me, get x 0.606530657, rounded to 3 decimal places, 0.607. I believe WebAssign wants you to round to 3 decimal places. Okay. One thing that if you're using the TI-83 or 84, you can get a fraction. If you want to open up, instead of doing the math key, another way to get a fraction to open up, you can hit the y equals, the alpha button, which is the green on mine, and then the y equals button, and then you just select option 1. This will open up a little box here, and it'll let you enter your answer as a fraction, or enter your input as a fraction. So this will enable to get a fraction. This is one way. The other way is you can hit the math button, and then you hit option 1 for fraction, and then it'll convert something that you've put in there. But this is nice. It opens up the little box. If you have a different calculator, it's different steps that you would follow. All right, the next one is the exact same thing for number 20. We're going to subtract the 7 first. And we get 3 ln x equals negative 2 over, or just negative 2. Then I have to divide by 3. ln x equals negative 2/3. Same thing, it's in log form. I'm going to turn it into exponential. So again, remember the little assumed e here. So we're doing e to the negative 2/3 power equal x. So go ahead and just do this on your calculator. You should be getting x is equal to 0.513417119, rounded to 3 decimal places, 0.513. On this slide, when I did numbers 19 and 20, I was just plugging in the answer for the x. And again, there was no calculations to do on it. So these are all good answers they did check. The 1 with a log 10. Oops. Number 21. Now, my goal here is to isolate the log. So I need to divide both sides by 2. And now I have log base 5 of 3x equals 2. It's in log form. I can't solve this in log form, so I'm going to turn it into exponential. So I'm doing my Bay trick. So I'm going to be doing 5 squared equals 3x. I'm going to figure out what 5 squared is. Set it equal to 3x. Divide by 3. And x equals 25/3. If I plug that in, it does not make my original problem negative, so it's good. It checks. All right, let's try the next one. Same thing. I want to isolate the log and then turn it into exponential. So divide by 3. Log base 4 of 6x equals 3. And now it's in log form. I can't solve it like this. So I'm going to go ahead and do my Bay trick. So I'm going to be doing 4 to the 3rd power equals 6x. 4 to the 3rd power is 64. Divide by 6. And x equals 32/3. So you can leave it as an improper fraction. So for 23, we need to condense this down to a single log. Then once we get it into a single log, we can go ahead and do exponential here. So the plus sign tells me that this is a product. So I'm going to condense it down. Log 5x times x minus 1 equals 2. I need to distribute the 5x. So this ends up being log 5x squared minus 5x equals 2. Now remember, whenever there's no little base here, it's assumed to be a 10. So what I'm going to do now is I'm going to turn this into exponential. So using my Bay trick, base, answer, exponent. So I'm doing 10 to the 2nd power equals 5x squared minus 5x. I need to square the 10. And now I need to set it equal to 0 so I can solve for x. So I'm going to subtract 100. 5x squared minus 5x minus 100 equals 0. I'm going to factor out a GCF of 5. 5, and then divide. And now I have to factor the trinomial. Factors of negative 20 that give me negative 1 are going to be negative 5 and positive 4. And now to find the value of x, set each of the factors equal to 0. So 5 equals 0. I don't need to do anything here because there's nothing to solve for. That was setting that one equal to 0. Then the next one. and then this one. Solve for each. So this one, add 5. Over here, subtract 4. My original equation was a log equation. I need to check it. As soon as I come up here to my original, and if I plug in the 5, so I'm plugging in 5 here to 5 times 5, that one works. If I plug in a 5 to this one, to the x minus 1, 5 minus 1 is 4, it works on that one. But as soon as I plug in this negative 4, right into the first one, 5 times negative 4 gives me negative 20. So this makes this one no good because it would make the the number that I'm trying to find the log of negative, so I get rid of that answer. So the only answer here I want to keep is the x equals 5. 24, we're going to do the same thing. We need to condense first. Now, this one I could actually do 2 different ways, but I'm going to solve it the same way I just did. I'm going to condense first. So the plus sign tells me I'm going to use that product property. So I'm doing log x times x minus 9 equals 1. I'm going to distribute. X squared minus 9x equals 1. Subtract the 1. Actually, I'm going to leave it like this because I'm doing BAE. So again, no little numbers, so that's a 10. So BAE. So 10 to the first equals x squared minus 9x. Now what I need to do is set it equal to 0. So subtract the 10. X squared minus 9x minus 10 equals 0. I now need to factor this. Factors a negative 10 that give me negative 9. X minus 10, x plus 1. Set each of the factors equal to 0. Add 10. X equals 10. Subtract 1. X equals negative 1. I need to check. Now, when I plug in the 10, it works on both. Soon as I try to plug in this negative 1 right here, the log of negative 1 I can't do. So this answer is out of there. And my only good answer is the x equals 10. Now, the other way we could have done this, we still have to factor it, but one thing you can do is, one thing you should memorize is that the log of 10 equals 1. Because if you think about it, this is a little 10 here, and if you do your BAE trick, 10 to the first is 10. So whenever you see a 1 in the problem, you could actually replace it with log base 10 or log base 10 of 10. Or if it were log of 100, that's going to equal 2. Because again, assume the little 10 there, 2 squared is 100. So the other way we could have done this is taken the 1 here. I would still have to condense. So what I could also do is condense it down, but then, so what I would do here instead is say log x times x minus 9, but then replace the 1 with a log 10. Then I could use the 1-to-1 property, but I'm still doing x times x minus 9 equals 10, distribute, and then I'm still right back at this step that I got to factor. So just know that you have options there. Either way is acceptable. Now I know I've sort of gone into the area for number 25, so let me just rewrite number 25 down here. So it's log of x equals the square root of log of x. So what I'm going to do here is I'm going to change this square root into a fraction exponent. So I'm going to turn it into log x raised to the 1/2 power. So then now what I'm going to do is get rid of this 1/2 power by squaring both sides. Now I could have just squared both sides the way it was, but I'm raising both sides to the 2nd power now. So then this cancels this. So now I'm left with log x squared equals log x. What I need to do here is get my logs on the same side. We did something similar to this at the beginning of the year, but without the word log. So once I move it over, now I have to factor out a GCF of x. So then what I can pull out, or a GCF of log x. So what I'm going to pull out is log x, and then I'm left with log x minus 1. And now it's factored, and now I set each factor equal to 0. Set this one equal to 0. And then this one as well. So for this one, I can assume a little 10 here. So BAE. Again, you should memorize that whenever you have log of x equals 0, x is going to be a 1. But let's turn it into exponential. And then anything to the 0 power equals 1. And then over here, I'm going to add 1. Log x equals 1. And then here, assume the little base. So BAE, 10 to the 1st power equals x. So x equals 10. And again, when you go back up and check this, they're both going to work because it doesn't make anything negative. All right, next one. So on this one, what I need to do is get my logs on the same side of the equal sign, and then I'm going to condense. So I'm going to subtract this one to the other side. I can't just cancel the logs. Even though there's one on the left, one on the right, the 3 doesn't have a log. So I'm going to go ahead and move this over, and then I'm going to use my quotient property and condense it. So log 11x plus 9 minus log x plus 4 equals 3. So then now what I'm going to do is use my quotient property and condense this. So 11x plus 9 over x plus 4 equals 3. Now I can go ahead and convert it to exponential. Again, remember you're assuming this has a little 10 here. So if you do your Bay trick, let me come over here to the side so I have a lot of room. So I'm going to be doing 10 to the 3rd power equals 11x plus 9 over x plus 4. Now, you could have also changed the 3 and made it into the log of base 10 of 3 of 1,000. But again, let's just do it this way with exponential. So I have to figure out what 10 to the 3rd power is. And 10 to the 3rd power is 1,000. And now again, I'm going to solve this as a proportion. Just going to add a 1 to the 1,000's denominator. And now I can cross multiply. So I need to distribute 1,000 to the x plus 4. And then 1 times the 11x plus 9 is just itself. So once I distribute the blue, I get 1,000x plus 4,000 equals 11x plus 9. I need to get my x's together, so I could subtract 11x. I get 989x plus 4,000 equals 9. Subtract 4,000. 989x is equal to negative 3,991. I'm going to divide both sides by 989. And once I divide this, rounded to 3 decimal places, gives me negative 4.035. Notice when I go to plug it back in, as soon as I plug it into this one, the x plus 4, as soon as I put negative 4.035 plus 4, this is going to give me negative 0.35. So this answer is bad because it makes what I'm trying to find the log of negative. So this would have no solution. The next one, notice they're both in exponential form. So because I can't change the base and make them both have the same base, I'm going to add in the word either log or ln. I'm going to add in ln to both. And then I'm going to use my power property. So I'm going to do the ln 6, and it's still raised to the x minus 3, ln of 3 raised to the 4x plus 1. I'm now going to use my power property, and I'm going to take this power and I'm going to pull it down to the front. So now I have x minus 3 times ln 6. And then here, 4x plus 1 times ln 3. I need to distribute the ln 6 to both and the ln 3. So once I distribute to both of these, this becomes x ln 6 minus 3 ln 6. Over here, I'm going to distribute as well. ln 3, so 4x ln 3 plus ln 3, because times 1 is just itself. My goal is to get my x's together and my constants together. So I'm going to go ahead and move this 4x ln 3 to the other side. So x ln 6 minus 4x ln 3 minus 3 ln 6 equals ln 3. All I did so far was move this to the other side. Yes. Now I need to move the 3 ln 6 to the other side. So I'm going to add 3 ln 6 to both sides. And now I have x ln 6 minus 4x ln 3 equals ln 3 plus 3 ln 6. I need to factor out a GCF of x from the left side. So once I divide this by x, I'm left with ln 6 minus 4 ln 3 equals, and this side stayed the same. And now my last step is just to divide. I'm dividing both sides by ln 6 minus 4 ln 3. And once you do this on your calculator, rounded to 3 decimal places is negative 2.487. I do not need to check this one because my original problem was exponential. Now, when you're doing this on your calculator, you need to use parentheses. So you should be putting parentheses around the numerator, then hit divide, or hit around the numerator, put enter, then divide, and then parentheses around the denominator. So the way you should enter it into your calculator, you should be doing parentheses ln 3 plus 3 ln 6, and then I would hit enter, then divide, then parentheses ln 6 minus 4 ln 3, close the parentheses, and hit enter. And then you should be getting this decimal. Again, I can't stress enough, use the calculator that you're going to be using on the test on Friday to be doing the homework. Now, for 28, I can use the property that I memorized that the ln equals 1. Now, I can only use this when something is being multiplied to ln. So what I'm going to do is apply my power property here, and I could swing this down and make this x times ln minus 2 times ln equals, again, move the 4 into the front. And now what I can do is change all of these ln's to 1s. So then now I'm left with x times 1 minus 2 times 1 equals 4 times 1. So now I get x minus 2 equals 4, add the 2, and x equals 6. Everybody good there? Now, another way you could think of it as is whenever the base of this is the same as the base of the exponent, that cancels away as well. But again, here you'd put that back as a property or a power. It's easier to use your power property, and then whenever something is being multiplied to ln, it equals a 1. Let's try the last example. I'm going to go ahead and change this radical into a exponent. So I'm going to go ahead and, actually I can put it into exponential form. Let's just do that. So B, A, E. So I'm going to be doing 2, and what I can do here is 2 raised to the 3/2 power equals this. And I'm going to change this into a fraction exponent. So this becomes 2 times x squared raised to the 1/2 power. And then I'm going to get rid of the fraction exponent. So I can multiply or raise both sides to the 2nd power. That'll cancel. And now I'm left with 2 equals, 2 to the 3rd equals 2x squared. 2 to the 3rd is 8. Divide by 2. 4 equals x squared. Square root it. And x equals plus and minus 2. And they actually both work because where I have to plug it into is an x squared. So even the negative will make it become positive. So both answers are good because it doesn't make anything negative after I square it. So that is it for the notes on 5.4. So your homework tonight is the 5.4a. It has a lot of the prior stuff. And then tomorrow night's homework is the 5.4b. However, you now have enough knowledge to do both sets of homework if you choose. And again, I will be posting a review to start getting you ready for Friday's calculator portion of the test.